Okay, guys, in this lesson, we're going to talk about story graphs, and we will still be using linear functions. But you will see that in story graphs, we will have a constant rate of change, but then that rate will change to a different slope. So let's take a look. So here we're going to have real life situations, and let's look at these first examples. Example number one. You can see, and let's grab a different color pen, you can see that we have 1, 2, 3 different intervals in each of these. And so there is a story that's happening. And one thing is we always need to read the labels on each axis to see what is going on. So in this axis, and typically the X typically represents time because time is constantly going by. So as time goes by, as it increases, we can see in our first example that the distance from home, we're getting farther away from home. And then we have, so as time goes by, someone is leaving their home and they are either in a car or they're walking or whatever it may be, and they're going at this pace. And then time goes by, but they're not going any farther. So maybe they took a rest or made a stop, and then they continue on their journey. The one thing we're going to be looking at is the rates of change at each interval. So you can see that interval 1 and interval 3 are pretty much the same, but interval 2 has a slope of 0, so they just stopped and took a break. Here we see in our next example that in interval 1 compared to interval 3, they were going much faster. Then they took a little break, and then they continued on their journey, but at a slower rate because we can see our slope is not nearly as steep as it is in interval 1. Now, our third example, we don't start at home. At the beginning of time, when time is 0, we are away from home, and you can see we are coming toward our home. So in the first interval 1, we are moving again toward the home. We take a break, and then we continue until we get home. So always read your labels to see what the situation is telling you. So when interpreting a story graph, again, pay attention to the title. Here we have southeast snowstorm. So there was a snowstorm. Look at your each axis. So this represents hours. So as hour 1 goes by and our second hour and our third hour, we are looking at how much snow is accumulating. And then look at the shape of the graph. So the snow increased, then it stayed where it was, then it decreased. So maybe the sun came out and it melted some, and then it started accumulating again. So let's be specific and see which interval where the snow accumulated and fell the fastest. So the way we're going to do that is, remember, slope is the change of the y compared to the change of the x values. So use the values to find the difference. So from here to here, we'll call this interval 1. We can see that we went from 3 to 6, so that was up 3 units. And let me switch and get a color. So we went from up 1, 2, 3, so that was a change of 3, and we went over 1, 2 hours. So interval 1 is 3 over 2. So 1.5 inches per hour is how you could look at that. Then in interval, we'll call this interval 2, you can see that we didn't go up or down, it stayed the same. So we have a slope of 0. Then we can see from hour 4 to hour 8, from 4 to 8, so we'll call this interval 3. So from 4 to 8, that's over the next 4 hours, and that goes in the bottom. It went from 6 inches, and again, I'm using my numbers, from 6 inches down to 3, so it went down 3 inches over 4 hours. Now this negative just indicates that it decreased, okay? And then lastly, from hour 8 to hour 10, so this will be interval 4, from hour 8 to 10, that's over the next 2 hours, and it goes in the denominator. It went from, it went from 3 up to 1 inch. So it fell 1 inch per 2 hours, 1.5 inches per hour, you could say. So which one did it fall the fastest? Well, 3/2 is the largest. And remember, disregard the negative when you're comparing. And then when did it melt? Well, it started melting at the negative, so interval 3. Okay, between hour 4 and hour 8, it melted. And then when did it not snow at all? That would be between hour 2 and hour 4. And then when did it fall the slowest? That would be 1/2 is smaller than 3/4. And of course, it's smaller than 1.5 or 3/2. So the way that you will write your answers, we could name these like interval 1, 2, 3, and 4, or we can do it by hour. So it fell the fastest between hours. So our number 1, our interval 1, that's from hour 0 to 2. It fell the fastest. It melted between hour 4 and 8, so between hours 4 and 8, and it didn't fall at all between hour 2 and 4. And then it fell the slowest between hour 8 and 10. Okay, let's look at this graph and determine the rate of change. So here in interval A, and look, let's look at our X. So it's going from 2 to 230 to 3. Okay, so they're going up like by 30, and then we have 15. So from 2 into 230, so 2 to 230, so that's 30 minutes. And if we write this in as hours, 30 minutes is 0.5. It went up from 0 to 40, 40. Well, I want to make this a whole number, so I'm going to double this to make this 1 hour. So I have to double this. So we're going to call this 80 miles per hour. Let's look at interval B. So it went from 40 to looks like 90. So from 40 to 90 is a change of 50 over, so that was from 230 to 330. 230 to 330 is 1 hour. So this is 50 miles per hour. And then from 330 to 4, it did not, there was no distance. So this was simply 0 miles per hour. That's when they had a rest. And then we have, so again, this is 90. I'm just using my intervals over here. Excuse me, my numbers on the y-axis. So from 90 until it reaches, so from 90 until 200 is 110. So it went up 110 miles. And then it went from time, it went from 4 to 6. That's 2 hours. We're doing this in hours. And then we just divide that, okay, to get it miles per hour. And that gives us 55 miles per hour. So the fastest interval would be A. Okay, this was 80 miles per hour. Interval B was 50 miles per hour. C was 0 miles per hour, and interval D was 55 miles per hour. So again, always read your numbers, read the axis of what it represents, and just make sure that when you do average rate of change, it's the change of the y compared to the change of the x. So we're not going to create a story, but let's just look at these a little bit. So again, you can see that somebody is leaving home, they're resting, and then they're using the same rate as they did in interval 1. In this one, somebody ran, they rested in interval 2, and then they picked back up, but maybe they weren't running, maybe they were walking because this is a slower rate of change. And this one, someone's was maybe, let's just say somebody spent the night at somebody's house and they were coming home. So they were coming home in interval 1, and then they took a break, and then they picked up with the same speed as interval 1, and then they came home. In this one, we're talking about time and temperature. So as time goes by, the temperature is increasing. So let's say that we have a cup of coffee in interval 1, and we are heating it up, we are boiling it or we're making it, and then it sits and rests, and time goes by, and it just stays at that temperature, and then we heat it some more, and we can see interval 1 and interval 3, they're going up at the same rate of temperature. Okay, in this one, we are heating something up in interval 1. It doesn't increase in heat, it just stays the same. And then we heat it up in interval 2, but not as at the rate as interval 1. In this last example, we have something that's heated up and it's cooling down. So in interval 1, it cools down. Interval 2, is just staying the same temperature. And then in interval 3, it's cooling down again at the same rate as interval 1. So the important thing for these guys is knowing you're reading the axis on each of these, and then comparing different rates of change if they're the same or if they're different. So interval 1 and 3 here, they are the same. But in our second example, 1 and 3 are different. 1 is steeper than 3. And I said we weren't going to create stories, but we just did. So hopefully this helps you.